overfitting and underfitting. Your model can fail in two completely opposite ways. It can be too simple to capture what is going on, or it can be so complex that it memorizes noise instead of learning patterns. Understanding these two failure modes is one of the most important ideas in all of machine learning. Let us start with underfitting. Imagine data that follows a curve, maybe exam scores that rise quickly at first, then level off as students study more. Now suppose you fit a straight line through that data. The line captures the general upward trend, but it completely misses the curvature. It is too simple. It cannot represent the real relationship. This is underfitting. High error on training data. Not enough flexibility to match the patterns right in front of it. Now the opposite problem. Suppose you fit an extremely wiggly curve that passes through every single data point. Looks great on training data. Zero error. But here is the catch. Real data has noise, little random fluctuations that do not mean anything. Your wiggly curve is memorizing that noise as if it was signal. When new data comes in, the predictions will be terrible. This is overfitting. Your model is too complex for the amount of data you have. Let us see this side by side. We fit three polynomial models to the same data. Degree 1 gives us a straight line, too rigid, misses the curve, that is underfitting. Degree 3 gives us a smooth curve that follows the general shape. It captures the real pattern without chasing noise. Degree 15 gives us a wildly oscillating line that hits every training point but swings absurdly between them. That is overfitting. Here is how you spot these problems. Plot training error and test error as model complexity increases. When the model is too simple, both errors are high. As complexity grows, both errors drop. But at some point, training error keeps falling while test error starts climbing back up. That gap is your warning sign. The wider the gap, the worse you're overfitting. The goal is to find the sweet spot. The level of complexity where test error is at its minimum. Not too simple, not too complex. Just enough flexibility to capture the real patterns without memorizing the noise. So remember, underfitting means your model is too simple and misses real patterns. Overfitting means your model is too complex and memorizes noise. You want the sweet spot in between where test error is minimized. Next, we will dig into exactly why models make errors, breaking it down into bias and variance.